Good morning, children. So now let us see question number 8. Prove that sine 6 theta into cos 3 theta minus sine 8 theta into cos theta upon sine 3 theta into sine 4 theta minus cos 2 theta into cos theta is equal to tan 2 theta. So let us take left hand side. So this is your left hand side. Now in numerator, for this sine 6 theta into cos 3 theta, for this we can use that formula 2 sine a into cos b formula, but here we can see that 2 is not there. Okay, yeah. So what we'll do, we will multiply and divide by 2. Okay, so in numerator we'll multiply by 2, and in denominator also we'll multiply by 2. So in that way there will be no change, okay, in left hand side. So that way we'll get this. Okay, when we'll multiply numerator and denominator by 2, we'll get this. Now for this 2 times sine 6 theta into cos 3 theta, we will use that formula 2 sine a into cos b formula, and that way we'll get this. Okay, same way for this 2 sine a into cos b formula will give us this, and for this 2 times sine a into sine b formula will give you this, and for this 2 cos a into cos b formula will give you this. Okay, in order to do these questions and all, you have to remember this formula. Okay, this formula you have to know, otherwise you'll have problem solving this type of questions. Okay, so now open bracket. Okay, open the bracket in numerator and denominator, so you'll get sine 3 theta minus sine 7 theta, because here sine 9 theta and here minus sine 9 theta will get cancelled. Here your cos theta and here minus cos theta will get cancelled, so you're left with this. Okay, and your denominator can be written as this. Okay, and this minus sign can be taken in numerator, so you will get sine 7 theta minus sine 3 theta upon this. Now you can use that formula sine c minus sine d upon formula for this numerator, and cos c plus cos d formula for your denominator. So you will get this in numerator, and for denominator you will get this. Then here cos 5 theta cancel, 2 cancel, 2 cancel, you are left with tan 2 theta. Okay, next is tan 2 pi upon 3 plus x into tan 2 pi upon 3 minus x is equal to this. So let us take left hand side. So here what I have done is I have converted this radian into degree, okay, for both. So I got this. Clear? Now this 120 can be written as 90 plus 30. So we can write this 120 plus x as this. Okay, same here. Now you can see this is 1 into 90. Okay, 1 into 90, and 1 is odd. Here also 1 into 90, 1 is odd. So tan will become cot in both the cases, and whole of the angle lies in second quadrant, and in second tan is negative, so I get minus cot. Here also I get minus cot, so minus minus plus. Okay, so now this cot 30 plus x, and here cot 30 minus x, so can be written as cos 30 plus x upon sine 30 plus x into cos 30 minus x upon sine 30 minus x. Clear? Now we have cos here, and here also we have got cos. So what we can do is we can multiply and divide by 2. Okay, so now here we can use that formula 2 cos a into cos b formula, and for denominator we can use 2 sine a into sine b formula, and by that we'll get our numerator as this, and denominator will get this. Cos 60 you know, so you can put the value half, and then take LCM, simplify, and you will get your right hand side. Question 9.1. Without using log tables, prove that half into cos 3 pi upon 13 plus half cos 5 pi upon 13 minus cos 9 pi upon 13 into cos 12 pi upon 13 equal to 0. So let us start with left hand side. So this is your left hand side. Now what we can do is here half cos 3 pi upon 13, and here half cos 5 pi upon 13. And for this you can see it is in product. Okay, here is also cos, here also cos. So what we can do is we can multiply and divide by 2, and then we can use that formula 2 times cos A into cos B formula for this one. Okay, so when we use that formula we will get this. Okay, so you get this cos 21 pi upon 13 plus cos 3 pi upon 13. Then open the bracket. Okay, and what will happen is this half cos 3 pi upon 13 and here minus half cos 3 pi upon 13 will get cancelled. So you are left with this. Now here you can see that in each term half is common. Take it out. Then you can use cos C minus cos D formula, and you will get this 2 and this 2. Okay, and you can see over here you get 2 times sin pi into sin 8 pi upon 13, and sin pi, that means sin 180 is 0. Okay, so in that way this whole thing becomes 0. Okay, so that is your right hand side. Number 2, 1 upon 2 times sin 10 degree minus 2 into sin 70 degree is equal to 1. So start with left hand side. Right now we cannot use any of this formula. Okay, so what we'll do is we'll take LCM first, so we get this. Now you can see here it is 4 sin 70 into sin 10, so this can be written as 2 into 2 sin 70 into sin 10, and then for that 2 sin 70 sin 10 you can use that formula 2 sin A into sin B formula. Okay, for this part you can use that sin A into sin B formula, and you will get this. Okay, simplify and you will get 2 times cos 60 plus 2 times cos 80. For 60 you know. Okay, so 2 into half, so 2 cancel, so 1 minus 1 0, so you are left with 2 cos 80 upon 2 times sin 10, so then 2 cancel. Okay, and this sin 10 can be written as sin 90 minus 80, and this would become, this is 1 over here. Okay, 1 into 90, so sin will become cos. Okay, and this is in the first quadrant and sin is positive, so you will get plus only. Okay, cos 80, so cos 80 cancel, you are left with 1. Okay, so this is your right hand side. Next is prove that cos alpha minus cos beta minus cos alpha whole square plus sin alpha minus sin beta whole square is equal to this. So start with left hand side. Okay, and for this part we can use cos C minus cos D formula. We will get this. For this part you will use sin C minus sin D formula. You will get this. And then take the square. Okay, so we'll get 4 into sin square this to this plus 4 cos square alpha plus beta upon this and this, and here you'll find something common, that is 4 is common, and sin square alpha minus beta upon 2 is common. Okay, so you are left with this, and this you know that it is sin square theta plus cos square theta, that means 1. Okay, because here alpha plus beta upon 2, here also alpha plus beta upon 2, so sin square theta plus cos square theta is equal to 1, so you get this. Okay, so that is your right hand side. Now question number 15, if cos x plus cos y equal to 1 by 3 and sin x plus sin y equal to 1 by 4, prove that tan x plus y upon 2 is this. So here cos x plus cos y equal to this, so we can use that cos C plus cos D formula to simplify this, so we'll get this. Okay, put this as equation 1, and for this second part we can use sin c plus sin d formula to simplify. So we'll get this, put this as equation 2. Okay, then divide equation 2 by 1 and you will get tan x plus y upon 2 equal to 3 by 4 proved. Question number 18. If x into cos a plus y into sin a equal to x into cos b plus y into sin b equal to k, show that this. So here for this question we'll use that cross multiplication method. So here we are given this one, okay, and we have to show this. So given x into cos a plus y sin a equal to x into cos b plus y sin b equal to k. So here you can see two equal to signs are there. So that means this is equal to k and even this is equal to k. Okay, so that way we'll get this and this. And in next step what we'll do is we'll bring this k on left, this also on left, so we'll get two equations. Okay, so you can see these are simultaneous equation. Okay, x y, here x y. So if you recall this formula, if you have got simultaneous equation, okay, a1 b1 c1 a2 b2 c2, then you have to use this. Okay, and that way you can find the value of x and y. So here solving by cross multiplication we will get this. Okay, here your a1 is this, your b1 is this, your c1 is minus k, your a2 is cos b, and your b2 is sin b, and c2 is minus k. So we have got this, and you know the formula. Okay, this is how you have to put the values. So put the values, okay, and you'll get this. And then I'm just naming the first one as 1, second one as 2, and third one as 3. Okay, and here in the first one you can see that this becomes plus, and here k is common, so I got here k. Here also I get k common, so k for the second one. And here you can see that this is cos a into sin b minus cos b into sin a. So this is nothing but sin b minus a. Okay, so now what I will do is, once I will put first one equal to third one, and then I'll put second one equal to third one. Okay, and that way we will be able to show this one. Okay, so first one equal to third one, so we'll put like this. Then for this part you will use that sin c minus sin d formula, and you can simplify this one. Okay, and this sin b minus a, okay, this can be written as 2 times, okay, I can like multiply and divide by 2. Okay, so this can be written in this manner. So this will become this. Okay, and reason is this. This is the reason. If you have sine theta, okay, then this can be written as 2 times sine theta upon 2 into cos theta upon 2. So here in place of theta we have b minus a. Okay, so this can be written as 2 times sine b minus a upon 2 into cos b minus a upon 2. So using this formula, okay, this can be written as this. Okay, and then you'll see that here 2 and here 2, they get cancelled. Then your sine b minus a upon 2 here, and here we have these two will get cancelled. So you're left with x upon cos b plus a upon 2. This k goes in numerator over here on the right, and k upon cos b minus a. So one part is done. Then put 2 equal to 3, and similarly you'll solve and you'll get this. Okay, and you see that in equation 3 you have got k upon cos b minus a upon 2, and for 4 also you got k upon cos b minus a upon 2. Okay, therefore using 3 and 4 you get the desired, okay, value. So that's how it is proved. Okay, and this is all for today, and this is how chapter 6 gets over.